Check, check. Hey, everybody. Welcome out tonight. Thank you so much for coming. Big thanks to @Task for sponsoring this, bringing us some good food. I'm really proud, actually. This is our 12th meetup, which means next month is our 1-year anniversary, which I'm pretty stoked about that. I had no idea it was going to be this big when I started this. But I'm really proud of the fact that we've never had pizza in 12 months. Like, thanks to @Task for making that happen. That's awesome. Maybe we can do it next month just since we haven't for so long. Anyway, thanks everyone for coming out. I'm really excited for our speakers tonight. Joe Eames, I've been trying to get Joe to come since our very first one, I think, actually. We finally got scheduling to work out. So Joe Eames is here tonight for a talk about testing with Angular. And then also Dave Geddes is going to talk about Overmind, which is a library thing he'll explain it. I can't explain it as well as he can. Other than that, we'll have some lightning talks after everything is done, if you've got one. And I got some raffle stuff. We got information for the Wi-Fi and group membership discounts if you're a member of the meetup. If you haven't actually joined formally on meetup.com, you're missing out on a chance to RSVP and stuff, just so we know who all's coming. But you also get some discount codes with O'Reilly. We get 40% off their print books, 50% off their ebooks, which is pretty cool. Egghead.io has given us 33% off their memberships. And then we just got this month Front-End Masters who signed on. And I've got a raffle from one of those three. I'll surprise you at the end, but we'll do a raffle at the end as well. So turn it over to Joe.
Is this on? Oh, okay, it's on. Good. When Matt asked me to talk, we had some discussions about what to talk about in testing. I think that I'm pretty well known as being a huge testing advocate, especially in the front-end world. So I was really excited to have an opportunity to come and talk to you guys about testing. So I talked with Matt again today, and he says, it could be about a lot of different things, kind of take it wherever you want to go. So I want to talk a little bit about me, and then I'll talk a little bit about what I'm going to talk about. So I'm an author for Pluralsight, which is an online video tutorial company. They have a subscription service for $30 a month. They have 3,000 plus courses and quite a few dozens on Angular. I've authored 4 or 5 of their Angular courses and in the middle of doing another one. So if you want to learn Angular, it's a great place to do it. I'm also a panelist on the JavaScript Dabber podcast, and we just started up Adventures in Angular podcast as well about 3-4 weeks ago. So if you're looking for more Angular goodness, it's cool because it's the creators of Angular on, people that are building cool products talking about Angular, and that's adventuresinangular.com, I believe. I'm also one of the organizers for NGConf, which is the first and best Angular conference held right here in Salt Lake City. Utah seems to be a mecca for front-end things. If you look at the Google Analytics, Utah is ranked #1 for searches about about Angular, which is funny. I mean, even California, where there are way more developers, and obviously that's where Google lives and Angular is born, the still #1 place is right here in Utah. We got a lot of big-time people. So we have a conference here, and the announcement as to when next year's is going to take place is going to be any day now. But even though all those things talk kind of about who I am and what I do, that isn't relevant to what I'm going to talk about today. What I want to talk about today has to do with my passion. So I want to talk to you about what I'm passionate about so that you can understand why I'm going to talk about what I'm going to talk about. I started out developing before people were developing on the internet, and then I started developing on the internet in '99, which is about when most companies started thinking about getting on the internet. And I was a server-side developer for all those years. I happened to be .NET. Don't hold that against me. But I went through a lot of phases in my career, and in about 2005, I taught myself to test drive code. So I taught myself to TDD. And once I did, I was really enamored with it. And a little bit later on, I got into the software craftsmanship movement and started attending a software craftsmanship user group, which is held up in Sandy every month. But I really got passionate about building good quality software, which is why I got it. I've always been a fan of education. I like to teach people things. And I like teaching people how to develop awesome software. And there are two parts to that, obviously. There's the tools, and then there's the techniques. Tools are very important, right? If you build an app today in jQuery only, it will take you forever to build the same thing that you could if you used Backbone. And if you use Backbone, it will take you 5 times or 10 times longer to build the same thing as if you used Angular. So tools are very important when it comes to building good software. And it is really hard to write worse code in Angular than it is to write worse code in Backbone. And the same thing is true between Backbone and jQuery. The tools have a lot to do with that. But on the other side of the tools is the techniques. There are lots of different ways to produce software. I'm sure everybody's heard of Agile and pairing and all these sorts of things, and testing is something that people talk a lot about. But test driving your code, or testing first, is one of the techniques that you can do when you're developing your code. And on the front end, it doesn't get a lot of traction because it's very difficult on the front end. Not a lot of people are doing it. And when Miško invented Angular, he was a tester. He was a big-time tester. In fact, that was his job at Google, was to help other groups test. And so when he put Angular together, he built Angular to be testable from the ground up. From the ground up. So what does that mean? Well, that kind of means that doing Angular without testing is similar to dating Brad Pitt or Angelina Jolie and not kissing them, right? That's what Angular was for, is for testing. And if you're not testing your code when you're writing Angular, you're really missing out on as big a benefit as the fact that you can write the same thing in 1/10 the lines of code that you can in Backbone or jQuery. So testing is very important. But it's not just testing, because testing after is, in most cases, a fool's errand. And I'm going to talk about that. So I'm here to talk about test-driven development and why you should be test driving your code in Angular. So first off, what is TDD? Who can tell me what TDD, test-driven development, is?
What it stands for?
Yeah. Well, no, what it stands for. What is it? Describe it to me.
I mean, it's having a test for each function that you do, and you write the test before you start developing.
Write the test before you start.
What it is in the view, you write a test for it, and then you actually start writing the code.
Awesome. Anybody want to add to that?
So from what I understand is you write the test based on the acceptance criteria, you fail it, and then you run your code until the test passes.
Awesome. Good. Good addition. All right, good. So there's a phrase, red, green, refactor. Anybody heard this phrase before? Well, you've all heard it now. Red, green, refactor means we write a failing test, then we make the test pass, and then we refactor our code. Okay? It's very simple, but doing it can be very difficult. So this implies something very important. There is no code until you have a failing test. You do not write any code at all until you have a failing test. You don't begin writing code. You don't even make a directory for your project. Well, that's not true. You do have to make a directory for your project. But no code until you have a failing test. Okay? You only write the code that will make the test pass to get it to green. Whatever the shortest path is between where you're at and getting it to green is the code that you write. Okay? You just want the test to go green. There's a reason for that, and that is if you write too much code, because you're writing what you consider to be the right code or the best code, there's a really good chance you'll break something. So write just the code that'll make the test pass. Then comes the very important part, which is refactoring. Okay? So that's the form or the function of it. Let's move on to the benefits of test-driven development. Okay? Let's start off by talking about better code. If you used, now everything that I'm going to say here, I'm going to compare what you by yourself would do if you were test driving versus if you were not test driving your code. Okay? This does not mean that if you test drive your code that you will be a better programmer than somebody else, or that if you don't test drive your code and write code that you are not better than somebody who does. I'm telling you what you will do by yourself. If you test drive your code, you will produce better code than if you don't test drive your code. And there's a lot of reasons for that. First off, unit tested code has to be decoupled from its dependencies. In order for you to unit test, now maybe we should pause here for a second and talk about the difference between unit tests and other kinds of tests. Is there somebody here that wants to volunteer and tell me what the difference is between unit tests and other kinds of tests?
So, I mean, the way I define unit testing is I test like in C# or Java, I would test a class at a time, right? So I'd mock all of its dependencies. Everything runs in memory. I would never tip the database in a unit test. Right? That would be an integration test. And I think technically, like some people will say, you can go and call other implementations of classes, and you're still in the unit test as long as you're running in memory. And that's probably true. However, you kind of end up with a sort of spaghetti ball, where it's very difficult to maintain those tests. You know, you make a change in class B, it affects the test for class A, and you don't want to deal with that. So I just mock everything.
Awesome, perfect, I love it. So a unit test is to test a really small unit of code. Like he mentioned, it is possible for your unit to be bigger than a single class. That's rare. Fewer people test that way when writing unit tests than just test one class at a time, but it is possible. But whatever it is, a unit test is a very small piece of code, typically a single class, depending on your coding environment, a single file or an object, whatever it is. But that's it. That's all you test, is that one thing. Okay? So in order to test a unit of code, you must then decouple that item from all of its other units or dependencies. Okay? Raise of hands, who here can say that they agree with this statement? Decoupled code is good. Decoupled code is good. Lynn, you didn't raise your hand. You and I are going to have a fist fight afterwards. Decoupled code is much better code.
I'm selling tickets for that.
For those who don't know, Lynn actually trains as a cage fighter every day. Unit tested code is much better code. Or sorry, decoupled code is much better code, right? Because decoupled code isn't deep inside of other code. As you pull those two units of code apart and make their interfaces clear and distinct, it's much easier to reason about them, it's much easier to maintain them, and it's much easier to make changes to one without having to make changes, cascading changes to the other unit. All right? If you are decoupling your code in order to unit test, that means that you are very aware of the dependencies that a unit has. And as you're aware of that, and you have to mock those out, there's a little bit of effort every time you have to mock out a dependency. The more effort it is to mock out a dependency, the more likely you're going to say, all right, this is painful mocking out yet another dependency. Maybe I won't add another dependency to it, and I'll figure out something else rather than having a dependency. Raise of hands, who thinks this is a good idea? A class that has 15 dependencies? No. We got one dissenter over here, that's fine. There needs to be one in every crowd. Classes, units should not have 15 dependencies. They should have a low number of dependencies. There's no such thing as a right number of dependencies, it depends on the unit. But the lower the number of dependencies, the better. It's obvious. Unit testing your code will reduce code smells. For example, too many parameters. It's hard to unit test a class that has a bunch of parameters because setting up the test and running the test is a pain in the butt, especially if you're going to do it 2 or 3 different variations. So because that's a pain, it will cause you to not want to do it, right? If you're writing just production code, you're only doing it once, it's no big deal. But when you're unit testing and you're running it over and over again and constantly maintaining and adjusting that code, all those parameters are a pain in the butt. And many parameters is a bad thing. If you don't agree with me, then after Lynn, I'll take you on. Who here knows what feature envy is? Anybody know what feature envy is? Feature envy is another code smell, and that is when one class wants to be another class. And when I say class, I'm using the generic unit term here, class, object, whatever. When one object wants to be another object. In other words, this object is calling, object A is calling into object B many times, calling lots of different methods over and over again. Instead of calling it once and calling maybe 2 different methods, it's calling 12 different methods on object B. And it calls them in many different points. And if you were to draw a sort of a dependency diagram, it would look like this, right? I'm constantly calling you and having you do the work that I'm doing, and that's feature envy. That's a pain in the butt to mock out during testing. And so test driving your code will cause you not to do that because, again, you're writing the test first, then you're writing the code. When you write the test first, then all the things that are painful are things that you don't want to do because it's painful. So if you write your test first, you will do less of the bad things. And at the end, I want to talk about pain, and if I forget, please remind me to talk about pain. Test driving your code is easier than not test driving your code. And there are people who may disagree with me. And please, something else. If you disagree with me, please raise your hand and let me know that you disagree. I won't ridicule the way that I did Lynn, but I'm more than fine having a conversation about that. Please.
For me personally, it's I can't decide which way I want to take something, and I can't decide how I want to write the test. I feel like I'm wasting time. I write it one way, change it, write it again, write it another way.
Awesome. I love it. That's a great, great point. I feel the same way very often. When I'm writing a class, I'm not really sure, before I've written its collaborators, how it's going to interact. Should I be writing it this way or that way? I write it this way, and I write some tests for it, and then I change my mind, and I refactor it, write it a different way. But what would happen without writing tests in that scenario? Well, I'd write whatever code calls it, or write it first, assuming that whatever code calls it is going to be a certain way. And then when I got to the other code, I'd write it. And if it didn't quite match up the way that I wanted, I probably wouldn't refactor it. For one reason, I might be afraid it's going to break. But also, I spent less time thinking about that code and how it might get called. I'm going to talk about another point there. So if I spend more time thinking about my code, somebody might say I'm wasting time. Certainly my manager will. He'll think I'm wasting time if I write the same code 5 times. But what's more expensive? What do we spend more time on? Writing code or maintaining it? Maintaining it. So every minute that I spend making my code more maintainable, is that likely wasted effort? Not likely. It can be, but not likely. Really, if you'd have to be omniscient to know, but not likely. Let's go back to easier coding. And please, any other counterpoints you have to anything I say, please raise your hand. I'm all for an open discussion.
Yeah, one of the things that I've found when I try to do TDD is that I'm pretty good at it when I'm very familiar with the framework that I'm working in, and when I have a really clear idea of sort of the structure of the code. When the code structure is already kind of well defined and I'm just adding little pieces to it.
Mm-hmm.
But it seems to get like harder and harder the vaguer your problem is, and the more unfamiliar you are with the tools that you're using. And so it's like, it seems like it's really hard when you're starting a brand new project with TDD, unless you have a really specific idea of what you want to do already, whereas it's easier as things go on.
Awesome, great point. So if anybody didn't hear, it's talking about the fact that when your requirements are more defined and you know the framework well, it's easier to TDD than when the requirements are vague or you don't know the framework as well. So let me tell you about my story learning Angular. I was contracting at Pluralsight. I had friends there, and I was in between jobs and wanted something to do, and had some bills I had to pay, very inconvenient. So I took a job, 10 weeks contracting with them, because I'd been doing front end for a while, and they wanted to build an HTML5 video player. So it was just sort of an experiment. So I went in and I actually paired with one of their developers who knew the system really well, but didn't necessarily know the front end as well. And he and I decided he and I were supposed to build this HTML5 player. So I'd never built a video player before. I'd played around with HTML5 video, but I'd never really, all the requirements that they had, I've never done that. What we did was we built the video player using just raw JavaScript. And once we had proven that it would kind of work, then we threw 100% of that code away. And then we built it again, and this time we used Backbone. And we got a little bit into that, and I hated it. And we threw it all away. And then we were looking around for something, a better framework, and that was when I'd heard of Ember, and I started looking at Ember. And at this time, which isn't true today, but at the time, Ember's testing story was essentially nothing. I found one article on the web that had the keywords Ember and testing, and that was it. So that was a no-go. And then the guy I was working with, he stumbled upon Angular. It was right at the top there, Testable. So we'd never done Angular before. We had test-driven, but we'd never done Angular before. We were working in an environment that was very unfamiliar to him, and we were doing something that I hadn't done a ton of. So I wouldn't say I knew the framework super well, but we had proved a lot of concepts with video, HTML5 video, but there were certainly some things we hadn't proved. So we built that all brand new, but we test drove it all. Now, I tell you this because it's very important to understand, we wrote a lot of code that we didn't test drive. And once we knew how to write the code, we took that code and we threw it away. And we wrote it again and test drove it. There's a reason for that. The test-driven code was thought about better. It has all these attributes that we're going to talk about. The code that we just wrote just to make sure that it worked didn't have any of those things. We were just trying to make sure that we could figure out how to do something. And we were learning Angular at the time, and it was kind of hard. So for one thing, I definitely identify with that idea. It is way harder to test drive when you don't know the framework and you don't know the requirements very well or the environment very well. It is much harder. But there's a solution to that, but that solution requires a ton of discipline. And that is the willingness to throw away code after you know how to do something. Because what we wanted in the end was a highly maintainable product. Pluralsight's still using that same video player that we built today. That was 2 years ago. They're still using it. And it wasn't because we wrote crappy code. If we had, they would have rewritten it all. We wrote code that was good, maintainable code.
I would probably guess that while you were writing that first version of the code that you actually threw away, you were also interacting with the user, and you were able to, get to a more mature level of understanding the requirements of the project by writing that throwaway code first, and then it was easier to rewrite.
Absolutely. Very true.
That brings me up to the next question I have is, where does prototyping fit with TDD?
I believe that prototyping is very appropriate with TDD, just something that you do to prove that you could do something and throw away the code. So it obviously depends on what you mean by prototyping. If you're prototyping a product and you're just creating something that users can see to build the real product, then TDD that code because nobody's going to let you throw that away. Your manager is going to tell you to just build it and not redo it. I don't know how many times I've been in that situation where we said we're going to build a prototype, but we'll build the real product later. Hey, Trianfo. Lynn, have you guys ever heard of a situation like that before? Have you ever been forced to take a prototype and make a real product out of it? There's a hand in the back.
So like what you just described kind of sounds like pretty Nirvana to me, but like the organizations I've been a part of, like politically not feasible. Like I know Prototype, like they actually head up the software craftsmanship chapter here. So anyhow, it seems like organizations are quite different, but in my experience it would be like they slap a PhD in front of you, like do this as soon as possible. Like and then you're like, okay, I think I've done this sprint, okay. And I mean this like idea of like, well, okay, here's the plan, guys. This sprint, we're gonna build a throwaway version in pure JavaScript. And then next sprint we'll do a backend version that's also throwaway.
Right.
And then I don't know, I feel like a lot of times like they look at the finished product and they're like, oh, it works, great, let's move on to the next TSC. And that's like about as far, and like not to mention like the learning curve, like okay, this sprint we're gonna figure out how to do test-driven development in Angular. Like I mean, because like there's lots of little things like how you would mock this or thing. There's always little technological quirks that you're just trying to ramp up time.
Right.
Sneak it in. Ask for forgiveness information.
Yeah, I wish. So that's kind of what I do is like I sneak it in. I feel guilty every time I do this thing. Yeah. So what about?
All right.
I mean, if you don't work for like this exceptional software organization, like maybe now or later on in the game.
No. Let's talk about it. It sounds like you have something relevant to this.
Yeah, well, I think a lot of times it depends on how you, I guess how you structure the project, right? You mentioned like having a PSD and then having to, implement the PSD. And I do a lot of UX work, and I go to Angular because I can wireframe and prototype a lot faster initially. This is the proof of concept, and so that becomes rather than the traditional route where you're developing a wireframe, with Illustrator and presenting it, and then you're developing a Photoshop document. In order to compensate for that extra step, like we skip those steps and do an Angular prototype first. It's much easier a lot of times to get that in front of the user because they can actually click things and you can mock data up and figure out try and sell it, it kind of requires a little bit of modification of your design phase and your discovery phase. You can just, create HTML prototypes with Angular, then the time that you save doing, actual mock-ups with, OmniGraffle or Azure or Illustrator or whatever, then you can use that to buy some time for testing.
Right. Right.
Sorry, I'm just going to chime in. Basically, I did the first unit testing project at Access Data, right? The first code that was unit testable was done by me and my team. And the way I did it was, we got the art of unit testing, we read that book, we figured it out, because I had no idea how to do it, right? And then we just started padding our estimates for the unit test, right? We bought into unit testing. We believed it was going to work. Now, truth is, I had enough cloud access data. I didn't have to worry about getting fired over this, right? So, you have to kind of evaluate where you're at. But that's how we did it. We just said, we're going to do it. We're not going to get fired over it. We think this is important. The improved quality that you get out of it's important. And now it's unit testing is required at Access Data. You have to unit test your code, and if you don't do that, you're violating process. That's where management's at with it, because it's been successful.
Right.
But we kind of had to demonstrate the value of unit testing, and then I sent emails out, right? I went into the bug trackers and I said, look at how many bugs this team has. Look at how many bugs we have. I would do a merge. I would run the unit test, and I would see that they failed. So I knew something went wrong with the merge. I would send an email to upper management. I'm like, hey, take a look at this. Look at all this time I just saved you because I ran a unit test. It took 30 seconds to run. That's how I did it, and it was successful.
Awesome. So I want to not kill, I don't want to take all of Dave's time, so I want to move on from this. So let me give you my very short chime into that, and that is, nobody knows how long it takes to do something but you. Your manager can tell you all day long that it needs to be done by a certain time, but when you tell him it can't be done by then, it can only be done then, he can argue as long as the day is, but unless he gets somebody else to implement that code, in which case you might want to consider how much you enjoy that job. If he's willing to say, if you don't do it in my time frame, I will fire you. We live in an industry where we have some luxuries about what we do. And that doesn't mean that everybody should go and tell their manager, screw you, I'm going to do things the way that I want and how I want them. We have to be politic, and we all like our jobs, and we like our companies, and we want to make those things happen. But we do have, the fact is, nobody knows how long it takes to implement something except for you. Nobody knows how long it's going to take you to implement it. And even if they know that somebody else can do it faster, unless they're willing to have that person write every line of code at the company, they still have to rely on you to write some of that code. So utilize that to your advantage. All right, so let's go back to circling back around, easier coding. One of the things that's great about test driving your code is you're only worrying about one responsibility of the unit that you're building at a time. So you've already built, say you're building a shopping cart, right? And you need to add and you need to be able to remove items. We got the add working, now it's time to remove. At that point, your add functionality is fixed. You got tests that are running and making sure the add never breaks. You don't have to worry when you're writing the remove functionality if you break add, because your tests will tell you. That's functionality you don't have to have in your brain. Less functionality you have in your brain, the better. I can't remember who it was that said the biggest problem with programming, or the biggest challenge in programming, is having to think about too many things. I think he said the worst thing you can do in programming is think, because the more you're thinking, that means you're thinking about too many more things. It was kind of an exaggerated statement, but the point is definitely true. If you have to think about 10 things, the likelihood of you getting all 10 things right is very low. Another thing that's great about test-driven development is that you can triangulate on your solutions, okay? If you've ever had an algorithm that you weren't 100% sure how to implement the algorithm when you started writing it, then one of the great ways to arrive at the correct algorithm is to triangulate on the solution. So you can say, well, for example, there's a canonical exercise in TDD where you write the bowling game, a bowling game calculator, right? Which seems fairly easy. You're just adding up pins as people bowl them, but the rules are actually fairly complex. But what is extremely easy is to write a bowling game calculator that works when you have all gutter balls. That's a very easy thing to write. Then it's also pretty easy to write a bowling in calculator that works if it's all strikes, right? And so on and so forth. You can triangulate in on your solution. So again, this is related to the easier coding that you're thinking about less things. You make one case work, and then you make the next case work, and the next case work, and pretty soon you've got the entire solution coded up. Something that is not available if, in another method, because if you're not test driving your code and you don't have tests that cover all those cases that you have done, then when you add new functionality, you have no idea if you broke the existing functionality you've already written up. This is one of my favorites. You are coding from the client's viewpoint when you're test driving your code. The tests that you write are a client to the code that you are writing. So that means that however you craft this unit, this class, will be optimized for whoever is going to call it. So when you write the code that it will call this class, it's already optimized to be easy to call. You don't have to call 6 methods in the right order, each time giving it 12 parameters, because you wouldn't write your tests that way. You will write the most optimized code. You will be thinking about it. You will be thinking about the names of the methods from the client's viewpoint. You will be thinking about the names of the parameters from the client's viewpoint. And when it comes time to use your code, it's the client that's going to do it. So when another developer needs to use that same unit, or you need to use that same unit later on, it's already optimized for the client, for whoever is consuming that code. So the names are right, the parameters are right. That means you might often do something like bring in a parameter. Well, and this doesn't really apply in JavaScript since we don't have named parameters, but we have named internal but not externally named parameters. But whatever the method names are, for example, you'd be thinking about them from the external viewpoint, not from the internal viewpoint. Internally, you might think that this is method A, but externally, it's more like, add this to that, right? You're thinking about that from the client's viewpoint. That is one of the huge, huge benefits of test-driven development, is just thinking about your classes from the viewpoint of the code that consumes them. More time thinking up front. This is related to that comment we had earlier. If you spend more time thinking about your code, you're going to produce better code. And if you have to write tests for it, you have to think about it more. You have to think about what you're going to name things. You're going to spend more time thinking up front with test-driven development than you will without. Better unit test coverage. Theoretically, it's possible that if you test your code after, that you will still be able to test 100% of your code. But in the real world, when we're done writing our code and the pressure's on to ship it, and the unit tests still haven't been written, what do? We leave them behind. When we get to that one method that we wrote that's actually really painful to test, crap, it's going to take me like 4 hours to test this one method. And it's, 4:30, and I want to go home. What do? We skip that test. We always end up with much worse unit test coverage testing our code after instead of testing it before. Test-driven development helps avoid sloth and temptation, right? After we've written our code, do we want to spend all the time writing all those unit tests? They're kind of boring. No, I don't want to spend all that time writing all those unit tests. It's too boring. And my boss, if I write that other piece of functionality and have that done today, my boss will think I'm awesome. It's very tempting to do what will make me look awesome. When we TDD, we write very little extra code. Reason being, we don't write code until we have a failing test. So that means you're going to over-engineer less. If you over-engineer less, you write less code. If you write less code, you're actually going to be faster at writing your thing, your unit, your project, than if you over-engineer and try to handle every case. Documentation. Tests are great documentation. In fact, they're the only good documentation. Comments suck. Third-party API documentation sucks because it always gets out of date. The minute you touch your code, everything that you wrote documentation-wise is out of date except for tests. Because if the test runs, then it reflects reality. That's the only true reflection of reality in your code is the tests. And safer refactoring. Is it safer to refactor if you have test coverage? Doesn't really matter whether you test drive or test after. If you have tests around your code, it's going to be safer to refactor, right? Absolutely. You're going to have a lot more confidence. Who here has ever felt fear about touching some code? Right? And as we all know, fear is the path to the dark side, right? This is the only useful thing out of episode 1 except for the lightsaber duel at the end. Another thing that testing will help you do, and remind me, I'm going to come back to fear. One other thing that testing will help you do is avoid this situation. Who here can identify with this? All right. Pain. It was pain. I want to talk about pain as my last point. There is this premise on test-driven development, and that is that when you're test driving your code, certain activities are painful. Writing code that's highly coupled is painful. Writing code with too many parameters is painful. Writing classes or units that have too many lines of code is painful. The premise is that things that are painful are things that are bad for your code. Things that are painful when test driving your code are things that are bad for your code. And if you make yourself feel that pain when you're writing the code and not after. Who here has felt pain after they've written code when they go in and try to maintain it? We've all felt that pain, right? This thing is 150 lines long, and it goes in and out of itself, and touching this one line of code, this is painful. I've got to fix this because there's a bug, and it's going to take me 6 hours, and it's painful. We all feel that pain, right? It's better to feel the pain up front and avoid the situation than it is to feel the pain on the back end. And that is kind of, to me, the underlying reason why test-driven development is so effective, is because it puts that pain there in front of your face. You feel it now rather than in 6 months when it's mission-critical bug that you're trying to fix. So, Angular is highly testable. It is test drivable. You can test everything. You can test directives. You can test services. You can test controllers. If you guys want a reference because you want to test and you don't know how to test Angular, on my GitHub page, I have a repository. Please, Chrome, come up. Right here, this URL here, NGshopper, okay? It has examples of how to test services, controllers, and directives. And you can test filters too if you want. They're really just services that have a funny name. So this is a reference application. I wish that there was plenty of time to show you guys more, but Matt made the huge mistake of letting me talk about what I wanted to talk about. What I want to talk about is TDD because I want people that learn Angular to test their code and to test drive their code because you will write better code that way.
I was going to mention also, I've noticed a lot in Pointer, a lot of the examples are having unit tests put in the examples to show you how to write it, so that's helpful too.
Right. Awesome. Okay. So that is my final point. Test driving. Oh, it's Joe Eames, Joeeames. That's not going to zoom that in. I don't think I've got, let's see. Thought I had the zoom on, but yeah, just search NGshopper, it should come up. So Angular was built to be testable. Test-driven development is way better than trying to test your code after. So please, as you're learning Angular, as you're doing Angular, as you're writing your code, test drive your code. You will not regret it. Thank you very much.
Why don't you guys stand up, stretch, do a little dance while I'm getting set up? Don't dance, actually, please. Oh, there we go. How do you do it?
So plug this in to your USB.
That's it?
Turn this on. Okay, and this middle button is a laser pointer. If you ever want, you just hold it down. And then right is the next slide. This is the previous slide. It should just hook right up.
Perfect. Thanks, Joe. Okay, can you guys hear me okay? Is that going through there? Yeah. Awesome. Okay, let's go ahead and get started. I'll give you guys 20 seconds. All right, so I actually got quite a bit out of that, Joe. Great job, man. Joe and I go way back. We worked together in a previous life. My main takeaway from that was if I do TDD, I've got a way higher chance of getting to kiss Angela Jolie, so I'm going to keep doing it. Thanks, Joe.
Hey, Dave, are you involved in any conferences?
Oh, yeah, so a little bit about me. I go to conferences, like Joe mentioned. No, so I'm also one of the NGConf organizers with Joe and Merrick and some other guys. So I'm on the Angular working group. I like Angular. I converted their build process from Rake to Grunt back in the day. That was when Grunt was still cool. That was, you know. I'm a senior engineer at Domo, so I know a bunch of you guys. I know Shady Mike, Triumpho, I know Lynn. I used to work with Jason Lubin, so I got a lot of friends in the audience, so it's cool to be here. Today I want to talk to you about two things. So at Domo, we have a massive Angular app. It's probably one of the biggest Angular apps in existence. And we've learned a lot of things. And there's a lot of pain points that we've hit that other smaller applications haven't hit yet until you get to a certain size. So I want to talk about two things. One is called Overmind. It's a project for lazy loading Angular and modularizing your project. And the other one is called csstyle for organizing your CSS. So I'll jump in. Okay, so first, Overmind. Has anyone here played StarCraft? StarCraft 2? Okay, so you all know what the Overmind is, right? So in StarCraft, there's an alien species called the Zerg, and they are just these crazy creatures with claws and fangs, and they're controlled by this brain-like creature called the Overmind. So this Overmind controls all the little Zerg minions. So what overmind.js is, to introduce it, Domo used to have this giant monolith of an application. So a single Angular module called app, where we just shoved everything. So I can't remember how many thousands of lines of code we have of Angular. I think we're close to 100K of Angular code. And it's just, we've got like 20-something guys, UI guys, a dozen or so back-end guys, and the app is just getting bigger and bigger and bigger. In fact, I think we reached 8 megabytes of JavaScript coming down to the client. And with a single-page app, you load it all, right? So obviously, this wasn't going to work. I looked into a bunch of solutions for splitting up Angular apps, but it turns out Angular wasn't ever really designed for that use case. And so I built Overmind. Basically, what it lets you do is you split up your monolith into a series of small little apps. So you take out each feature, you try to separate it out as its own independent Angular module that can run completely on its own. And then once you've separated these out, the Overmind takes care of loading the features on demand. So instead of a big monolith, you have a small monolith, which you can rename to core, which is what we did. So the way it works is if you go to a route that starts with profile, for example, the Overmind will load the profile module. If you go to a route that starts with admin, it can be deeply nested, admin/settings/whatever. As long as it starts with admin, Overmind will clear the previous feature, clear the previous route, completely clean up and unbootstrap the app. And then it will fetch the code for admin, and then it will bootstrap the admin module in place. So overmind is a replacement for NGView. So if you're using an Angular or a UI router, I don't support that yet, but I plan to look into it. Currently, it's a replacement for NGView. Yeah?
If you bounce back and forth between modules that have previously been loaded, and are you taking advantage of like browser caching in some way where you don't have to like reload everything?
Good question. So his question was, if you bounce back and forth like this, are you taking advantage of any kind of caching so you don't have that hit? And the thing that loads the code is require.js, and require.js has that built in. So require, if you've already loaded admin, require isn't going to load it twice. The thing that does happen each time is the cleanup and the bootstrap. I don't hang on to any kind of state. I prefer to just clean up because it's actually really fast. We have some really big features at Domo. We go back and forth, and they tear down and set up super quick. Good question, though. Another one, Joe.
So, I assume it's correct that this is technically slower than if you just had one module, basically back to the monolith, after it had been loaded, but because you're unbootstrapping and rebootstrapping, and then bootstrapping a whole new application, so there's some overhead there. But what sounds like what you're saying is that it's unnoticeable.
Yeah, at least in our app, and we have relatively large features. So for us, yeah, so the trade-off is, do you want to load it up front, or do you want to load it when they need it? So our users, a good example is the admin. We have a relatively large admin feature that a very small percentage of our users actually ever go to. And we didn't want to pay the price of having to load that up front. And load time, some people will say it's not important for single-page apps because people are used to waiting for things to initialize, but it's actually not the case. Amazon did a study, and this is several years ago, but they purposely slowed down their website by 400 milliseconds, and it cost them, I can't remember, it was in the millions. It translated 1% decrease in sales for every 400 milliseconds. And for Amazon, that's a huge number. For Google, they slowed down their search ranking, or their search result page by, I think it was also 400 milliseconds. And for them, that translated to a loss of 70 million searches a day. So page speed, users are really impatient. 1 in 4 users will abandon site if it takes longer than 4 seconds. So with Overmind, it really helps cut down that initial load. And each feature in our app, each feature has its own build. So with require.js, admin gets built into its own file. All of its Angular templates get included. And it gets minified on its own and cached on its own. So if the user goes to admin, there's a single request to load everything that the admin feature needs, and then it runs. Let me move on. Here's how you use Overmind. It is a directive. Basically, you replace NGView with this. You configure the Overmind, so you tell it, hey, when the route starts with profile, I want you to load the profile module, and its file is located in here. So this is what tells require.js where to fetch the file, and Angular which module to bootstrap. And finally, for your module, you call config on your module, and you pass in this overmind.control. And what this does is it provides to your module some things that it used to get from UI router, or sorry, from the NG route. Namely, there's location, there's, gosh, I just spaced it. Location, route params, route. So basically, anything that has to do with routing is now owned by the Overmind. So your modules are no longer going to depend on NG route. Only the Overmind depends on NG route. But it provides to them the things that they need. So your app actually doesn't have any idea that it's being controlled by the Overmind, and it uses everything like normal. The only difference is it comes from the Overmind instead of having its own module. I saw a hand. Yeah.
Yeah, can you explain why you actually have to put a div in your page for Overmind?
The div with the ID.
It just seems like you could just like include a script somewhere and have all the functionality.
So when you initialize your application, the only thing you have to bootstrap is overmind. Rather than bootstrapping your app, you bootstrap overmind, and then overmind bootstraps your app. You do run one thing to just bootstrap the overmind. That's it. So I could combine that overmind and the div into one thing. In fact, I have a ticket in GitHub to simplify that right there. But yeah, you bootstrap overmind, you configure it, you tell it what to bootstrap and when, and then it handles the rest. Yeah.
So what does this do over just say, inside of Nginx, setting up each of my different apps to have a different, base URL route, using Nginx for that high-level route, and then using UI router inside of each individual app?
So I think, if I'm understanding you, the difference is you won't have a hard page refresh in between features. So it will feel like a single page app still, whereas if you split it up with Nginx as actual independent apps, then every time you go to something new, you'll have a page refresh, you'll have that white blank screen, which at Domo is a hard requirement that we can't have that. Someone tried to add it once and our CEO freaked out. So he's like, wait a second, what was that? So yeah, so it's going to feel like a single page app. So this is how you set it up. It's actually pretty easy. Let me show you a little demo. And this demo is hosted out there on GitHub. All right, I'm going to show you the code first. Wow, that's tiny. Can you guys really even see that? So over here, I've organized my project into just a folder of apps. So I've got an admin app, a home app, a nav app. So what's interesting about that is you can actually have several different apps on the page at the same time, and they have completely separate scope digest cycles, which is really neat. In Domo, we broke it up into 3 sections. There's the content, a sidebar, and nav. Which is actually really good because our sidebar, we're doing some crazy things in there. And anytime the main content changed, it would fire the scope digest of the sidebar and vice versa, which was slowing things down. So by separating them out, we actually doubled the performance of some of our features, which is pretty cool. Oh, and also, in case I forget, we cut out about 1 megabyte of JavaScript by using this from the initial download and sped up our page load by 2 full seconds, which is a pretty big deal. Okay, so I've organized it into these apps. I'm going to show you the admin app. There are absolutely 0 tests for this. And I also did the best practice of combining all your stuff into a single file. So this is an admin. It's got a controller, a couple different controllers. You'll notice that the routes are just the same as normal. Admin goes to this controller with this template. So when you're using overmind, it doesn't feel like you're using something different. Let me go ahead and show you. If we search our network tab, I'll refresh so you see I'm not cheating. If I search for admin, there's no code yet loaded for admin. But if I click on the admin link, the browser loaded my JavaScript. My admin module was bootstrapped into the app. I can even go into deep sections of it, and it all just works fine. Same thing with profile. Profile was just loaded. And go back and forth, and it just feels like a regular Angular app. We're using a thing called RJS Build Analysis. You can find it on NPM. Basically what it does is check for duplicates in your different build bundles. So if admin tries to include D3 and the profile feature tries to include D3, it will throw an error and say, hey, you're trying to include it in 2 places. So you'll never run into the problem where you've actually added to your build by having duplicate dependencies. Yeah, so that's it. Overmind, try it out. If your app is starting to get big, if it's starting to, the download size is starting to get kind of out of hand, Overmind should be a lifesaver for you. So that's Overmind. Any questions about it? Got one in the back?
How does it fit like Webpack? I'm not super familiar with Webpack, but I know like kind of the promise of it. You can build these bundles and
Yeah.
lazy load things.
Yeah. So the question is, how does this work with Webpack? The answer is it doesn't yet. So I actually really like Webpack. I'm using Webpack on one of my side projects, and Webpack is a replacement for RequireJS. They both can do a lazy loading story. RequireJS, you do it by specifying modules in your build config. Webpack, you do it by specifying chunks in your code. Either way, you still need some way to tell Angular how to handle lazy loading. So the only difference with overmind to support Webpack, all I have to do is have a different loader function. Right now I'm using require that just calls require, and then I do my bootstrapping. I'm going to make that configurable so you can, in fact, write your own loader if you're using something like, I don't know, Browserify or something I don't support yet. You can write your own loader function. So that's coming. Or if anybody wants to contribute, I'd love to accept a pull request for any of those. Yeah.
What do you do if you want to have some state preserved in the app, like you have something on the root scope, like a user or something like that, and you want to have that be preserved?
Yeah, so the question is, how do you share state? So usually you would do this with either you'd inject some common service or you'd stick it on the root scope. Once you're using overmind, each app has its own root scope, which is a good thing, and its own injector, which is also a good thing. So the thing that is shared between them is the overmind. So if you add things to the overmind, then they can be exposed, they can be shared. Or I actually wrote a function in the config. I don't think I have an example of it, but it's when you configure overmind, you can tell it to expose certain dependencies, and then they'll get injected into the sub apps. And so the sub apps don't have to care that they came from overmind, they'll just know that they have them. So there's ways to do it.
Is there an example of that out on your?
The code is there. I don't know if I don't think there is an example. I can add one though.
When you do that, are they using the same instance of that?
They are. Yep.
Can you explain a little bit more about include? So like, I still want in all of my modules, I want to declare what their dependencies are, right? But you're just talking about like duplicate scripting for this. Is that what you're saying? Or?
So switch gears from Angular to RequireJS for a second.
Oh yeah, yeah.
With RequireJS, if you make a separate build for different pieces, there's the chance that those separate pieces might include some of the same things like jQuery. You don't want to include jQuery twice.
Yeah.
So with RequireJS, you can tell a specific module to exclude other modules. So that's how you do that. And that tool just makes it easy to spot them. In fact, it makes it impossible to accidentally add them. Another question here.
So some of the problems that you've been solving with the lazy load modules and stuff, do you know if there's plans with the Angular core team to incorporate some of that into like Angular 2.0 or any of that?
Yeah, they've already solved all this in Angular 2. Yeah, so this is purely for 1.x. In fact, they are working on a new router to replace NGView, and I'm going to work with Brian to get some of these things into that. So UI router does not. No. I'm sure you could adapt this to work with it, but it doesn't have it out of the box. Yeah.
And have you done any memory profiling to see if the browser will actually unload the code from memory or anything like that? Because I'm kind of dealing with a similar situation, but it's going to end up being much bigger.
Yeah, I actually have in this very demo site you just saw. I run the profiler, and I'm clicking around, and the number of DOM nodes climbs, then it drops. The memory climbs, then it drops.
So the garbage collector does unload those modules.
Yep, it gets completely destroyed. In fact, more so than NGView. NGView keeps your previous view around for the sake of being able to animate. I took that out just for performance because we aren't using the animating between NGView. I could add it back in, but yeah, it cleans up. Anyone have the time? 7:10. Okay, I got maybe 2 more questions. Go ahead.
Wait, so that demo you showed, that's not obviously available on GitHub, or is it?
Yeah, I'll show you. So if you go to github.com/gedski/overmind, and I'm pretty sure, how does the GitHub branches work thing? Because I published that, the demo is on GitHub branches, or GH branch, or what's it called? GH. Pages, yeah. So that demo is hosted somewhere, but if not, you can see it here in the demo folder. Is that what it is? Yeah, that's it right there. So you can see it hosted, the demo. Okay, one more question on Overmind, and then I'll move on. Joe.
What size project would you say is big enough to use this on?
That's a good question. I guess if your page is taking, if you're approaching that 4-second barrier, that'd be a definite yes.
What about how big you think the app is going to be? So you're planning ahead and saying.
I don't think so. I don't think so. It's actually not too hard to move to this. Like Domo has been, our project is huge, and after I did the work of building Overmind, actually lazy loading modules with it is not too hard. The hardest thing, and if you want to be looking forward thinking, try to keep your features completely independent. The hardest thing is when they're tightly coupled. You've got the profile feature that is using some small piece from the admin, and then you're going to have to break them up and make a common folder. So if you want to be thinking ahead, I'd start there. But if your app is already starting to get slow, or if you know it's going to get big, you got a big team, or you're about to hire, then definitely use it. Yeah. If your tests are passing, you don't need it. All right. So the question is, do you get any organization benefits for using it? Yes, you definitely do. So in our project, we basically have a monolith folder where there's everything, right? And then what we've done is we've taken those out, the apps that have been lazy loaded, we took them out and put them into their own root level directory. So there's now an admin directory, there's a profile directory, and so on. And so when I'm working on one of these features, I know that I can just open up my folder and I'm completely isolated. I think Joe had a pretty epic quote about loosely coupled code is good code or something. It helps with that too.
And that's why I say maybe it would be arguably good to use this even if you have a kind of smallish project, but you just are trying to like isolate some services a little more.
Sure. And you can always break them up, have them be isolated, but still load them all up front with require if you want.
Yeah.
It's completely you have full control over it. Okay. I'm going to switch gears and talk about something else. Okay, so who loves CSS? This guy. Okay, are you for hire? Because seriously, the rest of us are struggling. Wow. Okay, I'll just turn this over to you. No. Okay, so CSS. CSS is awesome because pretty sure those are crushed souls rolled up into a ball there. Okay, so CSS at Domo at least is, we got a lot of guys, we're writing a lot of features, we're moving really fast. And our CSS is starting to get kind of crazy. We're using BEM. Has anyone heard of BEM? Block Element Modifier. It's a naming convention for CSS. And the other day, I was writing some CSS on a side project, and I found myself typing a bang important, and before I hit the semicolon, I was like, "What have I done?" And I didn't want my CSS on my personal project to become crazy like pretty much every project I've ever worked on CSS. And so I'm actually doing this thing on my side project. It's kind of cool where I'm using Trello to track it, and I alternate between feature and improvement. So I forced myself to, before the next feature, I forced myself to do some kind of some kind of cleanup feature to my project before doing the next feature. And it's actually been really cool for me because I tend to go one way or the other. I tend to either get kind of crazy on features and just build everything, and then I end up hating myself for not being like Joe. Or I tend to do the other thing where I just spend all my time refactoring, all my time cleaning it up, and then no features get done. So I've been alternating one and one. It's been awesome. We're actually trying it on my team now at Domo because I think it's going to scale pretty well. But anyway, one of those tasks was make my CSS awesome, because after I typed that bang important, I was pretty scared out of my mind. And so as I started thinking about CSS, I started thinking about all the problems that it has, not even for a big team, but even for just a little team. Like, I only had maybe 5 or 10 CSS files, but things were already starting to get kind of crazy. And so I'm using Sass. Anybody here using Sass? Or Less, or Stylus, or Rework, or any of those? If you're not, you should probably just kill yourselves now, because there's no hope. No, just kidding. Don't. That was insensitive, Joe. I'm actually here today to talk to you guys about essential oils. My favorite place to get essential oils is at State Street Grill in American Fork. They've got the best onion rings, and they also sell essential oils. I haven't figured out like why yet, but just as a side note, there is one oil called Thieves that's got cloves and like cinnamon and stuff. It's supposed to. Oh, I think their generic brand is called Germ Fighter. Anyway, it is not meant for sensitive areas. That's all I'm going to say. All right. Back to CSS. CSS. Anyway, so this little refactor cleanup task turned into this kind of spawned off on its own project. And I made a convention for my project that I started to really like, and then I coded up some Sass mixins to codify the naming convention that I made, and it turned into CS style. CS originally stood for computer science style of attacking CSS, but then someone told me that was pretty douchey, sounded pretty arrogant, so I renamed it, or I made CS stand for clean and simple, which I guess that works too. So I've published this out on csstyle.io. The benefits, one is that it makes your CSS scannable. People often talk about how good it is to have semantic HTML. Then you look at their CSS, and it's just a mess of selectors, right? So with CS style, and I'll show you some examples, but it makes your CSS scannable, makes your CSS semantic. So by looking at a CSS file, you actually know exactly the scope and application of every single rule. So when you're looking at a file, you'll know if you change something, where it's going to affect your app. Makes your HTML scannable because basically there's 5 different types of things you can write. And by looking at any class in your HTML, you'll know exactly where it's located in your CSS and its scope as well. CS style also makes it so you never have to worry about specificity again. How many times have you guys added like home in front of a selector, or header, or important is the worst case scenario? How many times have you done that just to override some stupid style that some other stupid person did before you, right? So specificity is a beast. This makes it so you can just kind of forget about it. And when you don't have to worry about specificity, it also means that loading order is no longer important. And this is actually one of the major optimizations you can do for performance in your app. If you've got 500 style rules, the browser has to check every single DOM node as a potential match for every single style. And so one of the best things you can do for performance is to leave off the styles you don't need until you need them. So along with the lazy loading, we're not doing this yet at Domo, but we're getting there. You can load the CSS you need for a feature and then unload it when you leave. But that's actually a pretty tricky thing to do if you have to care about which file is loaded and keep them straight in the right order, because they override each other. But with CSS style, or CS style, you never have to worry about the order. Another thing is consistency. Everyone's got their own kind of different styles. For CSS, it really helps having the whole team on the same page, writing everything the same way. Code reuse, style reuse is really important. And last of all, development speed. So if you're not having to spend time thinking about, oh, how should I name this class, or where should I put this style, you can go a lot faster. So let me show you a little bit about CS style. All right, can you see that? A little bit small. Okay, so this is the site, but I'm just going to show you kind of what you do. First off, it's very centered on components. So with Angular, this is perfect for directives. You with csstyle, you make a component. Where's that little laser? Ah, there you go. So with Sass, include is the way you use a mix-in. I'm going to support stylus and less and rework eventually, but for now it's just Sass. But you declare this component, this button component, and you put your styles in here. And then in your HTML and your markup, all you do is class equals button, and then here's the result. So that's pretty simple. You might be thinking, okay, well, I could have just done dot button. But let me show you where it gets even more useful. So it generates a class. I could make it generate an element for custom elements. It doesn't have to be a class. Right now, that's what it generates. I'm going to support custom elements, though. So components often have a lot of variations, especially if you want to keep your CSS kind of compact and not get out of hand. So when you want variations, that's when you get to options. Now I'm a big fan of the command line, and so I made it so that when you want to do an option, you pass it as an argument to the component using dash dash. So this is saying use the action option for the button component. And the way you define that is inside of your component, you declare an option, give it a name, and then give it some styles inside of that. And you can have as many options as you want. You can have a button dash dash large, button dash dash warning, whatever you want to do. But it just makes it really clear to know, hey, this is an option on the button. Any questions on this before we move on? Yeah.
Do you have additional levels of nesting below that?
I don't do 3 dashes, but I do have parts, and I think that's what you're getting at. So options are they're meant for the top level component. You can have the component change based on the option. But components can also be constructed out of parts. So parts are the child elements inside of the component. So if you have a large or a complex component, you can break it down into its parts and style each part. So the way you do a part would be is you give it the name of the component, then 2 underscores, and then the part name, so icon. So in this case, we define the part down here by calling the part mixin and passing icon as the name, and then we give it the styles. And that makes, so this would be the icon part. Now you may notice that inside of part I also have an option. So parts can have their own options, their own dedicated options. And so the usage of that was I have the button icon and I pass it the argument of rocket. So button icon declares the stylings for all the icons that I want to use. And then if it's the rocket option, I use a different icon font character. So this lets me reuse a lot of code and only have to put the least amount possible for the thing that's different with that option. So parts are just kind of a way to structure the components to build them up easy. And now when I scan my CSS, so I'm looking at this button component, a quick scan tells me, okay, here's the options and here's the parts, and this part also has an option. So it's really easy to quickly scan it and know what's going on. Yeah.
So does the order you put those things in the class matter?
They only matter if they have conflicting styles. But yeah, they matter because that file is going to be loaded all at once. Okay. So if you had, for example, parts wouldn't matter because it would be a separate element. But if you had, let's say you had 2 different options. You had an action option and a lame option. I don't know why you have that, but let's say you did. And they both set the background color. The one that's lower would win, like regular CSS. Because this basically just generates your selectors for you in a way that makes it a lot easier to work with. Any other questions about parts or options? Okay, so you're building your components, and then let's say you start realizing there's a lot of generic styles that could be applied to any components. And that's what I'm calling tweaks. So for example, our button, we've I want to make my button rounded, and rounded isn't really specific to a button, right? I could make anything rounded, and also give it kind of this glassy looking effect, and that's not specific to buttons. So I define those as tweaks. So you call the tweak mix-in, give it a name, and define its style. So I have a rounded tweak and a glass tweak, and then to apply those, it's just with the plus sign. So here's my button, plus rounded, plus glass, and it shows up like that. So tweaks are a great way to kind of refactor the common styles that you have in your components out into something that can be used across the board. And finally, the last thing you use are locations. And locations are like, let's say you've got a button on the home page that needs to look slightly different from everywhere else in the app. Now, oftentimes you can just create a new option on the button, but if your option is named home, that's a pretty good indicator that that's a very location-specific option. So rather than making a new option, you could just make a location. The location, you call the location mix-in, say the name, and then inside of there you can style anything. So inside of the home location, I'm styling the button to look slightly different. So now it looks like this. And to use locations in your markup, it's just @ location name. So again, if I'm scanning my HTML, I can see all my classes. I know exactly what type they are and their location, where they are in my project. So @home is a home location. Button is the button component. Action is an option to the button. Rounded is a tweak, plus glass is a tweak. And button icon is a part, and it has an option. So I know exactly where everything is. It takes kind of the guesswork out of the CSS, which is pretty cool. So that's csstyle. It's out on GitHub. You can try it out. I'm happy to accept pull requests for stylists and less as soon as I've locked down. And Joe, you are going to love me for this. So csstyle was actually test-driven. Bam! Yeah. So with the tests, if you're what? With the tests, if you're interested in how I did it, I've got the SAS files where I define things, and then my tests run, and I check that the selector is what I was expecting it to be, and I also check its specificity, which is pretty cool. So anyway, that's csstyle. If you like it, I'd love your help in getting the word out. I'm pretty connected in the Angular community, but not in the CSS community, so like 10 people have seen this so far. But it's been really useful on my side project, and we're going to start using it at Domo because it really helps organize code and kind of wrangle CSS. So that's it. Any questions on this? All right, thanks.
All right. Thanks to Joe and Dave for speaking tonight. Is there anyone that wanted to do a lightning talk tonight? We kind of went a little over on time. If anyone really wants to. Yeah, go ahead.
And my game show microphone. Cool. Okay. All right. Okay, well, it's good to see everybody here. So what I'm here to talk about, I'm actually friends with Jason and Matt, and I had the opportunity to talk a little bit about a new Kickstarter project that I just put up. It's called Jaxi the Robot. And basically, what it is, it's a game. Let's go to full screen here. All right, that'll work. It's a game that will teach kids how to code in JavaScript. So you got this little robot here, and she starts the kids off in really shallow water. So she basically starts you off by showing you just how to call a function. For instance, you control the robot just using some JavaScript here. Jaxi.run. All right, and there you go. And then, just little by little, you kind of add to what she can do. So, all right. And so eventually, you will get to the point where the kids will get to the point where they're going to be able to write one function that will help Jaxi traverse through the entire level and be able to go through. And by the time they finish playing the game, it's probably going to be about 40 levels or so, they're going to have pretty good working knowledge of JavaScript, something that they can take with them. It's aimed more at like 11 to 17-year-old children. And it's inspired by my daughter, who's a 3-year-old. And if you look around this room, how many female engineers are you probably calling out? One, right? I don't know if there any back there. All right, 2 right there. But it's kind of interesting that the industry is so not imbalanced. And so with my 4-year-old daughter, watching her play with her blocks and kind of acting a lot like her dad did when he was little, I just kind of see that, and I wouldn't mind trying to move that needle a little bit. But in addition to that, I had the opportunity to go to a local juvenile facility over in Provo, where there were some troubled kids. They had all sorts of problems. And so having the opportunity to go and talk to them and share them my personal experience, which is I'm just a high school graduate, but I've been blessed enough to have like a job in software engineering, and it's kind of been a way out. And when those kids heard that part of the story, they just totally lit up. And these are all boys, and I showed them Jaxi the Robot, and they loved it too. So that's kind of validation of it, of the character and of the game concept. So anyways, that's basically the gist of Jaxi the Robot. So does anyone have any questions? Yeah. Go ahead. Who first? Go ahead. Yeah. Go to jaxitherobot.com. I appreciate that. Thanks. Yeah, jaxitherobot.com. And the Kickstarter link is bit.ly/jaxitherobot. Okay. You had a question over here? That was my question. Same question. Awesome. Jaxi. Yeah. Jaxi. So I'm pretty excited about this part. Yes, Jason. So that's a good question. I tried it out with about 30 of those kids in that juvenile facility, and then I tried it with about 20 more or 15 more just from my neighborhood. And it was really interesting to watch them as they played. Sometimes they'd get kind of into a quandary where Jaxi would run into a problem, and I would think in my mind, oh my gosh, they're stuck. What are they going to do? And then I just kind of watched them as they tinkered and failed over and over and over. But then they kind of got to this point where, taking what they had learned, they kind of worked themselves out of it. And I'm thinking, that's exactly how you learn. I mean, you fail over and over, fail rapidly. So it was really cool because as soon as they had that success, that light bulb went on and they were like jumping up and down, pumping their fists. So it was really awesome to see that. Thanks for that question. Any others? All right, well, I'm going to need some help with this Kickstarter. It needs some eyeballs. So if anyone wants to tweet this out or anything like that, I would greatly appreciate it. Thanks, everybody.
All right. I'm looking for speakers for next month, so if anyone's interested, please hit me up. Also, correct me if I'm wrong, Joe, September 25th is the Salt Lake meetup, the next one. They meet up at Higher View on the third Thursday every month. So fourth Thursday every month. Last of whatever, so fifth if there is one, probably not a sixth. That'll probably be back around to ours on the second Tuesday. Other than that, I promise you guys a raffle. If you follow on Twitter, literally up to dollars. And we're going to hold true to that. This raffle is worth literally up to dollars. It's from Front End Masters. It's run out in Minnesota, and they do just kind of like trainings and stuff for front end development. They have been awesome to support us. They have given us 30 one-year subscriptions to raffle off. They're worth $390 a piece, so up to many dollars, I guess. Anyway, so how I'm doing this, I've just got a little JavaScript thing I'm going to run in the console of the meetup page that's going to randomly select someone that RSVP'd. Yet another reason to sign up on Meetup if you haven't already. Tyler Pexton. Don't leave early, sorry. Try it again. Joe Eames. Okay, that's fair. Yeah, you could maybe try and sell it for half price to someone else. Spencer Bean. Going. All right. My algorithm removes people after I selected them too, so you can't get selected a second time. Eric Sharp. All right, Eric, come talk to me after, and I'll give you the code. Anyway, thanks everyone for coming out. We'll see you next month.